This video is for the graphing exponential growth and graphing exponential decay notes. So we're going to start with exponential growth. So exponential, grab a new pen. Exponential growth is an exponential function where b is greater than 1, and as x increases, y increases exponentially. So we're going to create a graph of the exponential function f of x equals 5 times 1.5 to the x power. So the first thing that we're going to do is we're going to create a table for this, and we're going to round our y values to the nearest 1,000. So you kind of have to pick a value that you want to round to, because otherwise the decimals do get very long on these. So we're going to do 5 times 1.5, and the exponent key, and then we're going to use the x. And we're just going to go to the table. And so our first x that's listed in the table in our notes is -10. So in the table function on your graph, that's where you're going to go. So we've got 0.0867, and then we're going to go to -4. -4 is 0.9877, and sorry, I'm not rounding to the nearest thousandths. I'm rounding to the nearest tenths, hundredths, thousandths, 10,000ths. So I apologize. And then we go to 0, and 0 is 5, and then down to 1, and 1 is 7.5. And so once you kind of create a table to work with, you can graph those ordered pairs. So -10 is 0.09. So pretty small value there. So we're just going to kind of estimate where it would go, and it's pretty close to the y-axis. And then -4 is it would be 0.99 if we rounded to the hundredths. So getting close to the value of 1, and then 0 is 5, and then 1 is 7.5. And you can just connect your dots. Ooh. And so you know with exponential growth that it's going to continue to increase, and that when we go to the left, that this will never cross the y-axis. Alright, our next one. Jamie took out a college loan of $20,000 at 12% interest to help with the cost of tuition, room, and board. The function used to represent the amount he will owe after staying in college X years is f of x equals 20,000 times 1.12 to the x power. Create a graph to represent the problem. So again, we're going to do a table. So we're going to go back into our y equals, and we're going to do 20,000, 1.12 to the x power. Go to the table. So we're starting at 0 this time, and the value of 0 is 20,000. Now since we're talking about money, you've got two options. You can round to the nearest dollar, or you can round to the nearest cent, which would be the hundredths place. Alright, so 3 is 28,099. 6 is 39,476. Sorry. And then 8 is 49,519. Okay, so now we can start graphing. So our first value, 0, 20,000, would be about here. 3, and then about 28,000. So it's a little bit over, so I'm just going to put just a scotch, because these are pretty big jumps. We're jumping by about 4,000 each time. And then we've got 6 and 39,000. So 6, so I'm going to put that pretty close to the 40,000, and then 8 and 49,000, which is going to be just above 48 there. And so we're going to start at this point. And so you can see that this graph looks a little bit different, where this one continues on to infinity in both directions. This one starts at 20,000 and keeps increasing. And so that's our question at the bottom here is why is only quadrant 1 used for the graph of this exponential function? And so the reason for that is because this is a real world situation. And the x-axis represents years and cannot be less than 0. So our time can't be less than 0. There's no such thing as negative 1 years. You started at that amount and there's only an increase from there. And so the y-axis represents the amount of money owed and will not be less than 20,000. So no matter what, he's going to owe at least $20,000 to the college. And so it won't ever drop below that until he starts paying off the amount that he owes. Okay, so let's look at decay now. Decay is identical. Our graphs are just going to look a little bit different. Okay. So exponential decay is an exponential function where 0 is less than b and b is less than 1. And as x increases, y decreases exponentially. So our first one here is create a graph of the exponential function. F of x equals 600 times 0.75 to the x power. So again, the first thing that we're going to do is create a table. So we'll go to y equals, and we're going to do 600 times 0.75 to the x power. And we're going to go to the table. And for this one, we're starting at negative 1. So negative 1 is 800. 0 is 600. 1 is 450. 2 is 337 and 5/10. And 3 is 253.13. 4 is 189.84. 5 is 142.38. And 6 is 106.79. So again, I didn't round to the 10th, I rounded to the 100th, so again, I apologize, I kind of get going. Okay, and so once we have that table, we can graph our points. So negative 1 is 800, 0 is 600, 1 is 450, 2 is 337.5, 3 is 253, 4 is 189, 5 is 142, and 6 is 106, which is just a little bit above there. And again, when you have such broad of a range in between values, you just kind of have to guesstimate where those points will be, especially with exponential functions. So now we can connect our points. So we know it's going to continue to decrease. And again, if this went further, you know that this is never going to cross, going to the right, the y-axis. Alright, Connor's grandparents gave him a $20,000 car for graduation. However, due to wear and tear, the car loses 20% of its value every year. The function used to represent the value of the car after x years is f of x equals 20,000 times 8/10 to the x power. Create a graph to represent the problem situation. All right, see if I can get that to focus up a little bit. All right, so same thing. I'm going to go to our y equals function and type our function in to the x. Go to the table. So 0 here is 20,000. And then 2 is 12,800. 6 is 5242.9. And then 10, go down a little bit here, is 2147. Alright, so when we graph, the 0 is at 20,000, 2 is at 12,800. So these are counting by thousands, 12,000, 13,000, 14,000. So again, kind of guesstimate. 6 is at 5,200. So if this middle line is 5,000, it's going to be just a scotch above that. And then 10 is at 2,147. So just a little bit above that. And you can keep going if you want a more accurate. So 12 would be a little bit more than 1,500. So again, you can look at the table too. If you would like to get more points to make it more accurate, 1,300, and then 14 is at 879. So a little bit less there. If that helps you graph a little bit better. Okay. So we're going to connect our dots. And again, we know that going to the right here, it's never going to cross that y-axis. So this one also asks the same question. Y is only quadrant 1 used for the graph of this exponential function. And so, same reason we're talking about a real-world situation. So time, which is the x, cannot be less than 0 years, and the value of the car, which is y, will not be greater than $20,000.